Imagine Hubble turning towards Saturn, a golden planet wrapped in rings so perfect they almost look unreal. But in 2003, Hubble looked at Saturn in a kind of light human eyes can never see, ultraviolet, and suddenly Saturn changed.
The calm golden world became electric. Its atmosphere glowed in blue, violet, and shadow. Its rings stretched across space like frozen blades of light. And Saturn's south pole turned toward Earth almost perfectly. This was not an ordinary photo.
Saturn's rings were tilted about 27 degrees toward Earth, almost the widest view we can get from our planet. For a brief moment in Saturn's long orbit, Earth had a rare view of the southern face of its rings, the southern hemisphere, and the South Pole.
But hidden inside that image was something bigger than beauty. A story about invisible light, alien seasons, a planet so distant that sunlight takes more than an hour to reach it, and a telescope that revealed a Saturn no human eye could ever see.
Because sometimes the universe does not hide its secrets in darkness. Sometimes it hides them in light we cannot see.
Saturn has always looked impossible. Even through a small telescope, it does not look like a normal planet. It looks designed, balanced, almost too perfect to be natural.
But visible light only tells part of the story. Our eyes see only a tiny slice of reality. To us, Saturn appears golden because that is how its clouds reflect visible sunlight.
But ultraviolet light reveals something different. Ultraviolet light carries more energy than visible light. It interacts with gases, hazes, and high-altitude particles in ways our eyes cannot detect.
So when Hubble looked at Saturn in ultraviolet, it was not just making a colorful image, it was revealing a hidden layer of the planet, a layer shaped by chemistry, sunlight, atmosphere, and time.
Saturn has seasons, just like Earth, but Saturn moves much more slowly around the Sun. 1 year on Saturn lasts almost 30 Earth years. That means each season lasts more than 7 Earth years.
Imagine a winter that lasts 7 years, a summer that lasts 7 years, a spring that slowly unfolds across nearly a decade. On Saturn, seasons are not brief changes in weather. They are planetary eras.
Sunlight shifts slowly. The rings cast changing shadows. The atmosphere responds over years. And from Earth, Saturn's appearance changes as it moves through its orbit. Sometimes the rings appear wide open. Sometimes they shrink into a thin, ghostly line. Sometimes the northern hemisphere faces us. Sometimes the southern hemisphere turns toward Earth. But in 2003, Saturn opened itself to us. The southern hemisphere faced Earth. The rings were broad and bright, and Hubble captured the planet in ultraviolet light. The result looks almost unreal. Saturn's atmosphere does not appear as one smooth globe. It looks layered. Some regions glow brighter because high-altitude haze particles scatter ultraviolet light. Other regions appear darker because gases and aerosols absorb ultraviolet radiation. The colors are not what human eyes would see. They are translated from ultraviolet wavelengths into visible color. But that does not make the image fake. It makes it more revealing. False color is not decoration. It is a scientific language. It turns invisible information into something the human brain can understand. In ultraviolet, Saturn becomes a map of its upper atmosphere.
A world shaped by hydrogen, helium, methane, ammonia, sunlight, hazes, and motion. The bright and dark bands are not random. They are clues. They reveal how particles are distributed, how sunlight affects the atmosphere, and how Saturn's long seasons slowly change the planet.
That is why the ultraviolet image matters. It is not just beautiful, it is data. It shows Saturn as a physical system, a planet of rings, seasons, chemistry, and motion.
But perhaps the most powerful part of the image is the South Pole.
In 2003, Saturn's south pole was tilted toward Earth, giving Hubble a rare look at a region that is often harder to observe. The poles of giant planets are some of the strangest places in the solar system. On Saturn, the poles are mysterious worlds of wind, storms, and strange atmospheric patterns. Years later, spacecraft would reveal one of Saturn's strangest features at the North Pole, a giant hexagon, a six-sided jet stream larger than Earth, a geometric storm system that still fascinates scientists. But the South Pole has mysteries too. Powerful winds, vortex-like circulation, seasonal changes unfolding slowly over years. When Hubble captured Saturn in 2003, it was not just showing a planet at a beautiful angle. It was showing a season in progress, a giant world in southern summer. And because Saturn's seasons last so long, this single image becomes a timestamp in a cycle nearly 30 years long. That is what makes Saturn so different. On Earth, seasons change in months. On Saturn, they change across decades. A person can be born, grow up, and become an adult before Saturn completes one orbit around the Sun. To Saturn, our lives are brief flashes. To us, Saturn feels almost eternal. But even Saturn changes. Its atmosphere moves, its rings evolve, its moons tug and sculpt the ring particles, its shadows crawl across the planet. Nothing in the universe is truly still. Even Saturn, the symbol of cosmic elegance, is changing. And that is why Hubble matters. Hubble gives humanity memory. From above Earth's atmosphere, it can observe planets without the blur of air, weather, and turbulence. It can see invisible light, ultraviolet, and near-infrared. It can return again and again, watching worlds transform over time. Hubble does not just capture images, it captures change. The 2003 ultraviolet image is one frame in a cosmic documentary stretching across decades. Think about the journey of that light. Sunlight travels across the solar system. It reaches Saturn. It touches the rings. It scatters through the atmosphere. It reflects back into space. Then it crosses the darkness toward Earth. Hubble catches it. Scientists process it, and we finally see Saturn as it was. Every image of Saturn is a message from the past, a delayed postcard from the outer solar system. And in ultraviolet, that postcard contains secrets our eyes were never built to read. This is one of the greatest lessons of astronomy. The universe is not limited to human senses. Our eyes evolved for survival on Earth, but the cosmos speaks in every wavelength. Radio waves reveal cold gas, infrared light reveals heat and dust, X-rays reveal extreme energy, ultraviolet light reveals hidden chemistry. To understand the universe, humanity had to build new senses. Telescopes are not just machines, they are extensions of perception. They let us see beyond biology. And when Hubble looked at Saturn in ultraviolet, it gave humanity a new sense for an ancient world. It showed us that Saturn is not just a golden ornament in the sky. It is dynamic, seasonal, chemical, alive with motion, even though it is not alive. Its atmosphere flows, its rings shift, its moons orbit, its seasons reshape the way sunlight falls across the planet. Saturn is not frozen in beauty, it is active, a machine made of gravity, ice, gas, storms, light, and time. And the more closely we study it, the stranger it becomes. This is the power of astronomy. It reminds us that even giant worlds are temporary. The universe is not a still picture. It is motion, and Saturn is one of its most beautiful moving parts. Still, the image also reminds us how much we do not know. How exactly did Saturn's rings form? How long will they last? What drives Saturn's deep winds? What happens far below its clouds? How do long seasons transform the upper atmosphere?
Every discovery answers questions and creates deeper ones. That is how science works. A discovery is not the end of mystery. It is the beginning of a better mystery.
When Hubble captured Saturn in ultraviolet, it was turning invisible light into data, and data into understanding. But for the rest of us, the image does something just as important. It makes us feel the scale of reality.
Because Saturn is not science fiction. It is real. Right now, Saturn is out there, a giant planet turning in darkness, its rings orbiting silently, its moons circling, its atmosphere flowing in bands of wind, its seasons shifting slowly. Whether we look at it or not, Saturn continues.
That is both beautiful and humbling. We are small, but we built Hubble. We built a machine that could rise above Earth, look across the solar system, and see a giant planet in invisible light.
We cannot touch Saturn, but we can study it. We cannot see ultraviolet light with our eyes, but we can build instruments that see it for us. That is the human advantage.
Not size, not strength, curiosity. Saturn is enormous, but Saturn does not wonder about us. We are tiny, but we wonder about Saturn. And because we wonder, the universe becomes visible. The 2003 Hubble image is a reminder that every world has more than one face.
There is the face we see, and the face revealed only when we ask better questions. In visible light, Saturn is golden and calm. In ultraviolet, it is electric, layered, and strange. Every wavelength tells a different story. Every telescope is a different translation. So when you see Saturn in ultraviolet, do not think of it as just a colorful version of a familiar planet. Think of it as a hidden Saturn. A Saturn that was always there, but invisible to human eyes. The rings were always reflecting ultraviolet light. The atmosphere was always absorbing and scattering it. The South Pole was always part of a slow seasonal rhythm, but we needed Hubble to reveal it. We needed science to teach us how to see. And maybe that is the deepest message of this image. The universe is not hidden because it wants to be hidden. It is hidden because our senses are limited. Every time we build a better instrument, reality expands. Not because the universe changes, but because we do. When Galileo saw Saturn, he saw strange handles. When Hubble looked in ultraviolet, it saw hidden atmospheric patterns and seasonal effects. Each generation gets a sharper view. And still, Saturn remains mysterious. That is why we keep looking, because the solar system is not a finished story. It is an active frontier, and Saturn is one of its greatest chapters. A giant planet wrapped in ice. A world with moons that may hide oceans. A world with rings that may be temporary. A world where seasons last longer than childhood. A world that becomes alien again when seen in ultraviolet light. Saturn in ultraviolet is not just an image from 2003. It is a message. It tells us that familiar wonders can become strange again when we learn how to look differently.
It tells us that a planet can hide entire stories in light we cannot see. It tells us that time moves differently across the solar system. And it tells us that far beyond Earth, a giant world is still turning, still wearing its rings, still moving through its long seasons, still waiting for us to understand it.
Maybe that is why Saturn never stops fascinating us. Because it feels impossible. It feels designed. It feels like a dream placed in the sky. But it is real. And the deeper we look, the more unreal reality becomes.
This is infinite science. Stay curious, because the next hidden world is already waiting in the light we have not yet learned to see.